Principles of Bioproduct Separation Module 2 Filtration and Microfiltration Segment 5. With me again, Yusuf from Institut Teknologi Bandung. Previously, we have discussed about equipment for filtration, pretreatment methods, general theory for filtration, and continuous rotary filter. In this segment, we will discuss about laboratory tests. Laboratory tests is very important in designing a filter to have a good filtration process, which includes laboratory tests for cake compressibility, for pretreatment, and for washing efficiency. We need to carry out these tests, but in a simple manner. The test often fulfills the requirements in designing a filter and provide information about other potential troubles absent in the conventional theory. These include filtrate clarity, tenacity of the cake to adhere to itself or the media, ease of washing, cake cracking, and moisture content of the final cake. These factors are vital to the success of a filtration process. We must be sure that the experiments are conducted using the same materials as those planned for the larger scale. Contamination, temperature changes, and cell lysis may alter the physical characteristic of the biomass in unexpected ways. There are 3 laboratory tests that we can conduct prior to a large-scale filtration process. First, pretreatment. Second, final filtration test. Third, filter leaf test. Pretreatment. We can easily compare different pretreatments with a simple batch settling test. We fill a series of beakers of uniform size equipped with slowly moving agitators with equivalent quantities of broth. We add increasing quantities of flocculant to the beakers, and after arbitrary time, we allow the treated broth to settle. Then we measure a certain criterion of flocculation performance, such as supernatant clarity or filtration rate. Most often, we can obtain an optimum dosage of flocculant to use in the filtration process. Final filtration test. We can evaluate the performance of filtration for new culture, fermentation media, and new conditions using a Buckner funnel. In a typical case, we pre-coat the funnel with the desired filter rate. We then pre-treat 100 ml of whole broth and immediately filter the sample for a fixed time at a certain pressure drop. After that, we can measure the volume and clarity of the collected filtrate. For instance, data in the table shows that a flocculant of 1.2% gives a suitable compromise between filtration rate and filtrate clarity. The time determined in the test can be used to estimate the time required for large-scale filtrations. Although a lot of data must be collected to establish a reliable correlation, the results are reliable. The same test can also be used as an analytical tool to determine the best time to harvest a fermenter or to uncover potential causes for a slow filtration process. Filter leaf test. If we plan to use a continuous rotary filter, we need to carry out a filter leaf test. This equipment primarily consists of a broth vessel, filter leaf, graduated funnel, filtered vessel, and adjustable vacuum source. In addition, we need washing liquid and receiving vessels. The procedure consists of manually manipulating a filter leaf of known area through the sequence which apps that occurring during a continuous rotary filter cycle. We first pre-coat the filter leaf with a selected filter rate. We then place the leaf under vacuum and submerge it in the broth for a certain time for cake formation. We agitate the broth to give a uniform mixture during the entire test period. After cake formation, we withdraw the leaf and still under vacuum, we allow it to drain for a certain period. We then submerge the leaf in a washing liquid for a desired washing period. Remove it and dry the accumulated cake. We then advance the cake ring to expose the proper thickness of cake and filter cake and cut off the exposed cake. As a result, we have a fresh pre-coat surface for another test. The amount and quality of cake The amount and quality of filtrate, and the amount and effectiveness of washing liquid can be determined for each cycle of the drum, which are important in designing a large-scale filter. For the next segment, we will discuss about microfiltration. Until then, I am Yusuf from Institut Teknologi Bandung.